Unit 4, Lesson 3. So there are a total of 5 ways to prove two triangles congruent. We already have side, angle, side, or SAS. I'm not sure why it's writing all the way up top. We are going to talk about 2 more methods today. Tonight's lesson, tomorrow's lesson, you will learn about the last 2. So we'll have a total of 5 altogether. So as we introduced in the vocabulary, today's is angle, side, angle, where we need to have 2 angles corresponding in each triangle and the side included in between those 2 angles. In this example, the triangles are connected, so it looks like, because you can see the reflection over AB that would map ACB onto A prime, C prime, B prime. And we can see in the example here that if I adjust the angle P and Q, the 2 triangles stay exactly the same. I can adjust the length of P and Q, and it's just the same on L and M. The triangles are still congruent. So if we have 2 angles and a side included or in between those 2 angles, then the triangles are congruent. That is what angle, side, angle states. Our second method is side, side, side. Again, if all corresponding sides are congruent, then the 2 triangles are congruent. And again, we can see that there exists a ridge of motion that would map triangle ABC onto triangle A prime, B prime, C prime. Remember that when you reflect, you are reflecting over a line. You are not reflecting over a point. I see a lot of people making that confusion. So reflections are over lines. Rotations are about a point. So again, there must exist a ridge of motion or a sequence of ridge of motion that maps these triangles together. However, we don't need to show that all the corresponding parts are the same. In this case, we can just show side, side, side. So again, if I look back at this example here, I can adjust the length of QR, and the triangles will remain the same. I can adjust the length of PQ and PR, and the triangles will still remain congruent to one another.